So to begin creating our complex visualization, we'll need to create a cube. In our Shapes and Actors folder, we'll create another blueprint actor and name it A cube. Double click on that, and the same way we did in our sphere, recreate our scene, root, and replace. Also add a static mesh. Make sure again that it's the bottom one here, and name it SM cube. I'm going to change that static mesh to the cube. Make sure it's the shape cube, because that's the one that lies above the origin in the actor. And we're going to want that so that when we scale with our Z here, it scales up. Perfect. And then go ahead and set the material to MIMISF. We're going to change the color in this one from the complex visualizer, so we won't have to do it in the construction script here. Now we'll create our visualizer. Create another actor in our visualizers folder and name it A complex visualization. It's a hard word. We'll call it visualizer. The other one. To start, we'll create an array of linear colors. To create a variable, click the plus sign here and name your variable colors. To change your variable type, click on it, and then over here in the details pane, click right here and type linear color, and it should be right here. To make it an array, there's a shape right next to the selection of your variable type. You can click that and then click the 3x3 grid. Compile and save. Now we can add 12 colors to our array. I'm going to start with red in a full alpha, hit OK. And I'm going to copy my way down and progress by 0.5. Just like this. The whole way around. 1. And then when I have 2 1s, I'll digress by 1. Perfect. And we know we're done because if I added one more and took away the last bit of blue, it would go right back to red. Go ahead and delete that. Compile and save. Then we're going to create another variable, name it division, change that into an integer, and one more named trim. We're going to put those both back to a single variable. Compile and save. Then we're going to add our audio component and change its song back. Compile and save. So now what we're going to do is spawn our cubes. We'll go into the event graph, and on begin play, we'll create a for loop. by dragging out of the execution line. And in this for loop, out of the last index, we're going to drag out and type minus for integer minus integer. I'm going to keep 1 in here, drag out of this first one, and type minus again. Now we're going to drag in our division into the first and our trim into the second input nodes. Next, we're going to drag out of the loop body and spawn actor from class. And then we're going to take our A cube, drag the spawn transform out, and then click make transform. Align it nicely under here. And then drag location out and type plus. Click the vector plus vector. What we're going to do is right click on the first vector and split struct pin. We're going to drag out of our index from our loop here and type multiply, integer times float. And then we're going to drag that into our y. Then we're going to right click on this variable here in our multiply and promote it to variable. Name it distance. This is what's going to separate our cubes. We'll go ahead and change that to 50. Then we're going to drag our default scene route in, get our world location, and add those two together. That way they'll start spawning from where we have our default scene route placed in the world. If you right click on this return value, we can promote to variable and call it cubes. Notice here how it automatically knows that it's our actor cube type from the spawn actor node. We can go ahead and change this to an array. Click close on this, delete that, and drag our cubes back out. Get cubes. If we drag off of that, then we can add our new array. Make sure you type add into the search there. If you double click on this line here, you'll add a new node to the line. If you can hold control and then click and drag that, you can move it and reposition it around. This helps you do a lot of organizing in your blueprint so that they don't get all mangled together. If you drag out from that and type reroute node, or just RER for short, you can create another one. From that one, we'll set actor scale. And then drag our execution line. Remember, our execution line is what decides in which order our nodes execute. We're going to right click on this new scale 3D and promote to variable, calling it initial scale. Compile and save. Now in initial scale, we'll do 0.1 for X, 0.1 for Y, and 1 for Z. Then from our cube line, we're going to get our cube static mesh by typing cube after dragging out, just like this. And then we're going to set vector parameter value on materials, just like we did with our sphere. And remember to name it color. Now what we'll do is drag out our colors from my blueprint list. Drag out from that and type get. Now if we go over to our for loop, we can drag out our index and type mod. This will help us get a color from our list that isn't outside of the bounds. The way we can do that is drag out from colors and type length, and drag it into the mod. And then we can drag that mod into our get, and then drag out from our get into the vector parameter value for the material change. This kind of gets messy. So I think what we'll do is change it into a function and change it to be pure. To do that, highlight on the colors variable, the get, the length, and your mod, right click and collapse to function. You can name your function over here to get color from index. And then over here in your details, click pure so that you don't need an execution line. You can also change the input name to index and the output name to color at the bottom of your details here. Now that's much more neat. You can also drag them up to the top here to save room. Maybe create another reroute node by double clicking on the line and control clicking to drag it over. Perfect. So now what this will do is spawn a cube for however many that we have in our division minus the trim. For now, we'll keep trim at 0 and put division to 12 so that we can see if we have one of every one of our colors. Click save and compile. Make sure you drag in your complex visualizer and remove your simple visualizer, as I forgot to do here. Now you can see that we have 12 bars, one of every color. But now we need to start putting in our complex audio visualizations into those bars. Open up your complex visualizer. Right click on your background of your event graph and type tick. You'll want to add your event tick. Drag out of the execution line and type frequency spectrum. And then click on your calculate frequency spectrum function. Right click on the background in the grid and type get game time in seconds. Drag that into your start time. And in the time length, type 0.1. For your spectrum width, drag in your division and click get and drag that directly in there. I know that normally, in the beginning, we remove the trim first, but we'll do that afterwards in here. Drag out of your spectrum and type length. Drag out of your length and type minus for your integer minus integer. Drag out of your input for your minus and type plus. Keep one in there and drag in your trim and plug that into the first one, just like this. Now from your minus, we're going to drag up here and type loop. Make sure you click the for loop and not the for each loop. Control and click this out of the first index and drag it down into the last index. Now we're going to drag out of our spectrum again and type get. Click get a copy. Always keep things visually smooth for you so that you know what you're working with in front of you. Then we're going to drag our index into the get. We're going to drag it out of the get and type multiply. You can also use asterisks for short. We're going to multiply a float by a float. We're going to right click on that and create a new parameter. Name it scale multiplier. For now, we're going to keep that to 1. Then we're going to drag out of our cubes and type get a copy as well, and also bring the index into that. Then we're going to take that copy, drag out, and type set actor scale 3D, and drag our execution line in. Now if we right click on our new scale and split struct pin, we can plug in our original two values here, our x and our y, and then drag in our new z scale, which is going to be a more complex division of our sound. Perfect. So let's go ahead and see what that looks like now. Oh, I forgot to set my sound here. So in your calculate frequency spectrum, click on sound wave and type the name of your song that you selected. They're huge. So the first thing we'll do is drag this up a little bit and go back into our visualizer and change the scale multiplier down to 0.1. Now we can see that there's a bunch of them that are going upside down, kind of maxing out. To compensate for this, the first thing we'll do is go back in and change our divisions to 24. And then we'll see how many are maxing out the entire time and take those out with our trim. I counted 11. So we'll type 11 in our trim. Test that out one more time. Now we only have a few going upside down. So go back in your visualizer, in your event tick, where it comes out of your get, right here, drag out and type ABS for absolute. Drag that absolute into your multiply here, and everything will be positive. Compile and save. You can drag your visualizer back down. Now what we can do, because we took out that heavy baseline, is visualize that in these, just like our simple visualizer did. Go back in your simple visualizer, highlight all your code, copy it, go into your complex visualizer, and then click on your audio, open up your single envelope event, and paste that right back in there. Make sure you drag your envelope value down in here and delete this variable, because that's from the old actor. You can right click on this here again, call it scale sphere multiplier, setting it back to 5. Compile and save.